Hey guys, we are calculating perimeter in this video, and perimeter was taught way back when in like second or third grade. Perimeter is just simply adding up the outside edges of a figure. That's it. When you talk about the perimeter, usually it's about like a fencing problem, how much fence goes around a yard, you know, what's the length of the outside edge of the garden, something like that. Perimeter is just adding up the outside edges. It really doesn't get any simpler than that. Sometimes there's problems where there's extra numbers trying to trick you because they're inside of the figure, they're not part of the outside edge. But as long as you remember that perimeter is adding up the outside edges of a figure, it's so super easy. Let's take a look. So in this first figure, it just determined the perimeter of each figure. If I wanted to find the perimeter, I'm simply adding up all four sides of this quadrilateral. So I'm just doing 16 plus 8 plus 22.5 plus another 8. Okay, you would go ahead and do the math. Well, 8 plus 8 is 16. 16 plus 16 is 32. 32 plus 22.5. What do you think? 32 plus 22.5? 54.5. Good job. That's it. We always want to make sure we label our answers with perimeter as the basic unit. So there's feet around this figure. The perimeter would just be in feet. If it said inches, it would just be inches. We don't put any exponents. We don't talk about anything squared. Squared is for when we do area. Perimeter is just length. It's distance. It just gets the basic unit. Let's take a look at this next one. Also basic. Do you know what the name of the shape is? There's 5 sides. It is hopefully you said pentagon. It is a pentagon. And I'm just adding up all these sides. Doesn't matter even what side I start with. So if I start up top here with the 5, I would do 5 plus 2x plus another 2x plus 5 plus 3x. Now the only situation here is we just want to make sure we know how to combine like terms. I cannot start adding 5 and 2x together and get some other type of expression. They're not like terms. Like terms have to have the exact same variable with the exact same exponent. Now we're not working with any crazy exponents here. We either have numbers like 5 and 5, or we have variables, 2x, 2x, 3x. These three terms I can combine, 2x, 2x, and 3x. Remember, when you combine like terms, all you do is you just do the math with the coefficients. 2 plus 2 is 4. 4 plus 3 is 7. So 2x plus 2x plus 3x is just 7x. And then 5 plus 5 is 10. And that's my answer, 7x plus 10. And my unit is in centimeters. And so I just leave it as centimeters. Could I put 10 first and write it as 10 plus 7x? Absolutely. Because we know addition is commutative and it would not matter what order you write your final answer in. And then the last one. Let's see, this has 1, 2, 3, 4, 5, 6. Do you remember a 6-sided figure? I hope so. 4 is quadrilateral, 5 is pentagon. What's a 6-sided shape? I hope you said hexagon. It's hexagon. Okay, so if I go to add up all of these expressions together, again, doesn't matter which side I start with. If I start up here with x plus 4 plus another x plus 4 plus 3y plus another 3y, I kind of jumped around the figure, plus 7 plus 7, and I want to add all of these up. Again, I have to combine my like terms. So what I notice here is that I have an x plus an x. Remember, there's really ones in front of my x's. So if I ask you what's x plus x, that would give us 2x. Then I'm going to look at my next variable. I say I have a 3y plus a 3y. So 3y plus 3y would give us 6y. Good job. And now I have plus 4 plus 4 plus 7 plus 7. Well, 4 plus 4 is 8. 7 plus 7 is 14. What is 8 plus 14? It's 22. And so my final answer is 2x plus 6y plus 22. And these are just labeled units. I don't know if it's inches, feet, centimeters. It's just units. And so I would put UN at the end for units. That's it. I hope this video was helpful. Thank you so much for watching. Bye.